Hello everyone, welcome back to my YouTube channel. Hope you are all doing good. Now let's see what is this integration is all about. Friends, it is just one simple statement. It is the inverse process of differentiation. Now let's see what is this inverse process or the reverse process of differentiation. Let me consider one simple function x square and I'll differentiate it. As we all know, differentiation of x to power of n is n into x to power of n minus 1. So differentiation of x square will be 2 into x to power of 2 minus 1, which is 2x. So we get 2x. So differentiation of x square is 2x, and as I said inverse process, we say integration of 2x is x square. Now let me discuss one simple application which I come across about this integration and differentiation concept. Let me consider one canal and reservoir, and let's assume that the flow of water through this canal is some 2x. Due to the flow of water in this canal is 2x, it sums up and increases the volume of reservoir by x square. So this is the concept of integration. Now if the volume of reservoir is increasing by x square, then the rate of flow of water must be 2x, and this is the concept of differentiation. It's just a simple application about integration and differentiation. Friends, let's see how to put all these things mathematically. As you all know, differentiation of x square is 2x, and we say integration of 2x is x square, and mathematically we represent as integration of 2x is equal to x square, and this is the elongated s we use for representing integration. And let's see what is this dx and c. Guys, we all know differentiation of x square is 2x, but what is this denominator dx? So when we read this, we read as differentiation of x square with respect to x. So what is this denominator is representing is with respect to what variable we are differentiating. Same way here also, integration of 2x, this dx represents with respect to what variable we are integrating. So how we read this is integration of 2x with respect to x is x square plus c. Now let's see why we add this constant c. So this I've told differentiation of x square is 2x. How about differentiation of x square plus 5? It is also 2x because differentiation of constant is 0. So 5 is a constant and differentiation of 5 is 0. How about differentiation of x square minus 10? Even that is 2x because differentiation of minus 10, which is constant, is 0. Now differentiation of all these three functions resulted with the same 2x. Can we say the integration of 2x is just x square, or integration of 2x is x square plus 5, integration of 2x is x square minus 10? We don't know. So that's why we say integration of 2x is always x square plus or minus some constant which we don't know. That's why we call that as a arbitrary constant or constant of integration. So every time we integrate any function, we add one constant of integration. In general, if differentiation of f of x is g of x, we say integration of g of x is f of x plus c. Every time we write integral symbol, we must write with respect to what variable we are integrating. Otherwise, it will be meaningless. And since this constant of integration is not known, this integral we call it as indefinite integral. So whatever the problems we solve in the beginning is all indefinite integral. Now let's see what are the formulas we have under this integration. Now integration of sin x is minus cos x because differentiation of minus cos x is sin x. We know differentiation of cos x is minus sin x, so minus into minus it will become plus. Friends, we don't have any derivations of formulas. It is based on the definition, that is integration is inverse process of differentiation. We are listing out all these formulas. Now integration of cos x is sin x because differentiation of sin x is cos x. Integration of secant square x is tan x because differentiation of tan x is secant square x. So similarly, integration of cosecant square x is minus cot x because differentiation of minus cot x is cosecant square x. You know cot x differentiation is minus cosecant square x. So minus into minus it will become plus, and we have the inverse process here. Integration of secant x into tan x is secant x because differentiation of secant x is secant x tan x. So integration of cosecant x into cot x is minus cosecant x because differentiation of minus cosecant x, that is cosecant x differentiation is minus cosecant x into cot x. So minus into minus it will become plus. Now integration of 1 is x because differentiation of x is 1. Integration of x to power of n is x to power of n plus 1 by n plus 1. And here one condition, n should not be equal to minus 1. If it is equal to minus 1, the denominator will be 0 and the function will not be defined. Now let's see how this differentiation is x to power of n. So 1 by n plus 1 is constant, and differentiation of x to power of n plus 1 is n plus 1 into x to power of n plus 1 minus 1. So n plus 1 cancels and you get x to power of n. So this is the inverse process we have here. Integration of e to power of x is e to power of x because differentiation of e to power of x is same e to power of x. And integration of a to power of x is a to power of x by log a. Here the condition is a should be greater than 0 always because log of negative values and log of 0 are not defined. Now let's see how this differentiation is a to power of x. You know 1 by log a is constant and differentiation of a to power of x is a to power of x into log a. So log a cancels and you get a to power of x. Guys, this e to power of x and a to power of x are exponential functions. I have made a separate video about these exponential functions. I have provided the link in the description below, so please go through that link. Now integration of 1 by x is log of mod x. Why mod x? Because log of negative and 0 are not defined, so always it should be positive. Because we have differentiation of log x is 1 by x, so the reverse process is this. And integration of 1 by root x is 2 root x because differentiation of 2 root x is 1 by root x. Friends, I'll make one separate video about how to remember these formulas very easily just by spending 2 to 3 minutes every day. So for all the future videos, updates, please subscribe to my channel and hit the bell notification icon. Now let's see what are the rules of integration. The rule number 1. If we have integration of constant into function, we can take constant outside and integrate only the function. Friends, I have made one separate video on how to identify the constants and functions and how we can differentiate between constant and functions. So please see the description below. I have provided a link over there. So the first rule, take the constant outside and integrate only the function. Second rule, integration of function f of x plus g of x, etc, etc. So if we have sum of functions, we can integrate them separately. And the third rule, which is similar to the second one, if we have difference of functions, you can integrate them separately. And second and the third rule, you can combine it, or if you come across integration of sum and difference of functions, you just have to integrate them separately. If plus is there, write plus. If minus is there, you write minus. Now let me take some examples here. Integration of 3 into x square. So 3 is the constant here, so I am taking it out and integrating x square. Integration of 5 into sine x. So 5 is a constant and sine x is a function, so I can take 5 outside and integrate the sine x. Integration of cos x plus tan x. You know we have sum of functions, so I can integrate them separately as integration of cos x with respect to x plus integration of tan x with respect to x. Remember, whenever we write integral symbol, we should write with respect to what variable we are integrating. Here is another example. Integration of, we have sum and difference of functions. So first we'll apply integration separately for all these functions, and that's what I have done here. So integration of first function minus integration of second plus integration of third. Now when you consider integration of first function, in that we have constant into function, so I can take the constant out and integrate the function e to the power of x. And here is just a standard, we don't have any constant. And coming to the third one, we have 10 as a constant, so I'm taking 10 outside and integrating secant square x. So 2 simple or 3 simple basic rules of integration, and that's it guys in this video. And in the upcoming videos we'll see how to solve the problems using the integration formulas and these basic rules of integration. Thank you for watching, and please subscribe to our channel and hit the bell notification icon.